Proportions.
Oh my god!
Like peppers
Okay, I
and
thought you were gonna
watermelon
Not
on the
Phil, you
outside.
lied to me. I thought it was Phil. Oh, see, it is.
So close.
Oh, it was like yellow.
It's not mine.
Alright, so let's see.
March 17th. Oh yeah, you're very Irish, aren't you?
I didn't have time to stick around and ask
I'm wearing
questions.
green.
I had to get in, get a cupcake, and come back here. They're in C200.
Too much drinking?
Yeah. Yeah, they're having a party. They got plenty of food.
Too much drinking, mate?
Throw up the green.
How about that pie?
Planning on binge drinking this weekend. Sunday morning, he's gonna wake up. St. Patrick's Day. Start
You're gonna be.
binge drinking.
He's gonna be so drunk from the day before.
Who's binge drinking?
Nate. Nate.
No.
Right.
Go start.
I think Jared.
What are those?
Gin on Friday.
Waiting for
His
you.
goal is to
start
start.
it all starts Friday.
The goal is to peak on Sunday and then just die.
And then just sleep for 2 days straight.
We don't see Nate on Monday.
I'll boil it next to Baker's still
What a great way to spend your Wednesday.
He plans on binge
Is
drinking.
it? I think everybody's coughing right now. Like I've had.
Oh yeah, it's ridiculous.
Is it
I thought you were
allergies?
gonna say
guess
binge
it's
drinking.
allergies.
One doctor
What's like
told
everyone's
me
binge
that it's
drinking?
like the winter's been like warm, cold, and damp. So like we all it's like mildew going on.
Yeah, I'm like.
Mildew.
Kind reactions to
Yeah,
the
I'm
mildew.
called honestly 2 days.
Yeah, it's
I
really
would
funny
go home
gross.
and just
But
pack
yeah.
up a lung for like 2 hours.
I can never hack it all the way up, so like it comes almost up and then I swallow it again.
Oh,
It's
God.
disgusting.
Well, I just wouldn't have anything. I just
You gotta flavor it.
I know, right?
Flavor.
Alright.
Citrus.
Let's see, should we start this? Oh, am
No.
I on? Oh gosh. Hi.
You've been on.
Sorry.
There's like a minute and 30 seconds about Nate binge drinking and.
That was a joke. Those were the days.
It's on here.
I know, I'm just saying. For Nate's parents or whatever. They were kidding.
Or Nate. Nate's embarrassed.
Okay, so these are the two series that we know so far.
Quick
Well,
YouTube it.
I assume we know. They
Hopefully.
can kind of know.
Maybe.
And we've been able to write other series based on these because we were able to substitute. So when it comes time to finding different series, the one strategy that you have is take one we know and just substitute in some stuff. And or if it's geometric, you know the first term and then you know the multiplier, so you can just kind of build it like that. But what if I want to find the series?
Oh my goodness.
You're gonna laugh.
Such an evil.
For the natural log of 1 plus x.
Oh, you don't.
Yes.
You raise it to a power of a.
And then there's an E in there somewhere, and there you go.
Yeah, I don't think that's it.
We're
That's
so
it.
smart. We really are. You really are. I don't know that anyone is good enough to be able to actually figure this out. I would never.
Wait, just on.
Colin, go!
Wait, is that like? Is that people?
You're busy drawing a falcon. That's the best
Literally, I
one
sit there, I'm like,
How
what?
good is that?
You mean
Hold on, I'm
to
showing it
Is
to the
that
world.
log-
I need to
is
show. I'm
that
showing it to the
the
world.
same-
Alright.
Like, is that representing the one over
It's
the one?
yeah.
Look how
this
good that
going
is,
to
dude.
come
It's
into
perfect.
play. Do the derivative together.
What's that?
Is
Basically.
it just 1 plus x?
It is the best one.
So let me actually.
And
You
we're
integrate
smart
it.
enough to
1
get
plus x.
That's what you get for saying we're not smart enough.
I know, right?
If it's not 1 plus x, then.
And then you guess.
Coordination snap. What's that? It's
Okay.
the same thing she wrote
So
over there.
this is. I'm just writing it so I can look at it one on top of the other.
Teach us the 4 noble truths.
Oh.
That's
Right.
What?
It's all coming together.
Fucking everywhere. Fucking everywhere.
Together.
What the?
Okay. If we know.
Anyway.
That's on camera.
Maybe it was, maybe it wasn't.
I think it is.
I can go
The red
back.
lights on.
I know the
Well,
Falcons.
If we know that 1 over 1 plus x
Give me
is
a
this
spotlight.
series, how can I compare this to this? Is it the derivative or is it the integral?
The integral, not really.
Integration by parts.
Here to here, what would we do to this? We would take the integral, right? So like, as a side note, just FYI, don't forget,
Flipitals.
the integral of 1 over x plus
say
1
Boy, there's my food.
is the natural log of
Ever
x
value?
plus 1. Okay, another way to get a series is to take one that we already know and integrate every term of it.
Oh, what?
And it'll give us a new and valid series.
So you want
Right.
one
My
over
mind.
another. But wouldn't that be the absolute value of?
No.
Yeah, I guess
No, it
technically,
wouldn't.
but
Probably the
No.
best thing you've ever said.
so
Are you sure?
since I know this series,
Uh,
I can take the integral of this
Hamburger.
integral of 1 over 1 plus x is the natural log of 1 plus x. And I can also then take the integral of the entire other side.
That's right now named
And that is going to give me all the terms of this series. What? Will you stop it?
Conjure a
Kelsey
real
cares.
good. Look how good that falcon is though.
I know, it's such a quality
Conjure a real
falcon.
good falcon. We're just giving him a spotlight.
What's the integral of
1.
Okay.
0.
Okay.
Oh,
0.
1.
12.
X.
What are you guys doing?
Damn it, Nate.
It's Pi Day.
Dad, I think we gotta go back 2 months.
What's the integral
Nate.
of x?
X squared over 2.
Yay.
Yay.
Nate,
What?
you're catching
What's
on
the
now.
integral of x squared?
X cubed over 3.
What?
Yay.
Catching on now.
He was close.
You got it.
Alright, is
Oh,
it
Nate.
negative 1 to the n
No.
times x to the n plus
Oh,
1 over n?
what's going on?
It's so far off.
Not
it's
over
not
n,
even.
but over n.
And x over n.
Oh,
So, if I integrate every single term, I now have the series for
Hey,
the
what?
natural log of 1 plus x. Isn't that crazy?
That's bomb.
yeah.
I can
Yeah.
also integrate the series, general term.
Okay, so it's n to the 2, and
The
then
negative 1 to the n is probably going to stay. We'll have to just look at the n and make sure it should be n or should it be n plus 1. We'll get there in a second. Well, how do I integrate x to the n?
x to the 2n over 2.
N plus 1.
N plus 1. Add 1 to the power, put it over the new power.
I was close.
My mind.
See, I was close. I just
Blown,
had
right?
plus 1 on the
Yeah, that should be cool.
Now, the negative 1, if I put it to the n, does this work when n is 0?
Yes.
Yes. No.
Yes.
Did we just integrate the other one?
No.
Nate's
Yes.
like, I'm right.
It,
He
it
is
works.
right. It works.
It works.
How do you know?
Why does that
put
work?
n or n plus 1?
How do you get
For
x?
this part
About
and this
n plus
part?
No, for the.
Yeah,
For
where
the
do you know?
power of 1?
Yeah.
Because I know that when the first n I plug in should give me
It was
this.
11:40.
So it should
So
make
it's
it
like I
positive.
need to-
So if n is 0, negative 1 to the 0 is 1. That
I like the
works.
part where he
If I started this at
gets
1,
sent to Lake on fire.
negative 1 to the first is negative 1, and it wouldn't work. 'Cause
Where
I
do you
need
get
it to be positive.
N plus 1 for the x.
That's like just the integral.
I took the integral of this, so like the integral of x to n
Oh, you
power
did
is
integral
add 1
that
to the power,
too?
put it over x.
Ugh.
The double
Yeah.
whopper with
So you got it. You've got a
So
series.
happy.
You've got a series now for the natural log of 1 plus x.
Which is boy.
The reason why that can be useful is they might also ask you.
Who is they and why do they ask so many
The
things?
natural log of x squared plus
Watermelon
2.
sugars.
A watermelon reference?
Yeah.
Find a series for a
Square
track.
one. So yeah, like the integral of it. It's pretty good.
Find a series for x times the natural log of 1
Yeah.
plus x.
Is that ultimately trying to find like the sigma part or whatever?
Yeah, ultimately the sigma part.
Delta.
Alright.
But
Ep-
they also
epsilon.
want the terms too.
Epsilon.
Isn't that like
You don't you just
the
multiply
same
x
thing?
squared?
There was another
Multiply
part
each one by x.
Yep.
To
So
be
if
x
you
squared
see
minus
this-
x cubed over 2.
You guys stop talking. Yes. If you see this, the idea is if you're able to like see that, oh, I already know that series. I'm just multiplying that series by x. I'm not gonna like substitute anything. I'm just gonna go to the series I already know and multiply every term by x. So like this is gonna be x squared, and this will be x to the third over 2. And this will be x to the 4th over 3, and x to the 5th. Do you know what I mean?
Yeah.
Ba 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 ba. Now, I just stop and think about this. There's obviously an alternator. But how can we do the n? Because I don't know that it's going to be... Can we just make this n plus 2
Over n plus 1.
over n plus 1?
What?
Yeah, that works.
Yeah, I think that
Wait,
works.
what is, how would you,
I just kind of, so in thinking, some of it is a little bit intuitive. So first I think, okay, if I just mess with this function, this series, I mean, I didn't mess with the bottom of it. So the bottom should be able to stay under 1. But what I did was I threw an extra x into every term. So I basically multiplied
Wait, x to the first.
x to the first times everything I already had.
And you just add those exponents.
So what do I do with a power? X to the first times x to the n plus 1, I add powers. So this is really negative 1 to the n times x to the n plus 2 over n plus 1.
Crazy.
Right?
I hope so. Now it is.
Yeah. So
There it is.
Is there any like
Here, dog.
aspect to this that like has a purpose, or is it just like
Just put
it's
a
the
full
same.
pack in
It's
there.
like being able to take a function and rewrite it as a series. So this function, this series, and in fact, wait, let me double check before I say this. Oh no. I don't even know.
That's okay.
It's only if you're going to teach calculus.
This only converges, and I'm not sure why. This only converges for x between 1 and negative 1, but it actually does converge when x is 1. What?
Why not?
was that the natural log one?
Yeah, this is the interval of convergence.
And that means, what does that mean?
So
Like-
what? So good
Where the
question.
graphs like equal each
Let
other.
me explain that again. So an interval of convergence means, and let me back up even before that. So the whole idea is you have a function and a series. These two things, if I graph them, if I graph this and I graph all of these terms, they look exactly the same. They're the exact same graph. But they're only the exact same graph on the interval of convergence. So if I graph this and I graph a bunch of these terms, it should look exactly the same from negative 1 to 1. But that's it. So past negative 1 to 1, whatever they look like, I have no idea. That work like that?
Maybe.
Whatever natural log of x plus 1 looks like this, and so does this. But then past that, the one might go like this, and the other might go like that. Like, I have no idea. But they would look totally different. But from negative 1 to 1, this graph and that graph are the same. That's what the interval of convergence means. Okay. Is that okay? Let's look at one more. Now, what's that? I don't know. I just went and checked it, and it says it equals 1. So I don't know. Let me say why. Do you think?
Because it says so.
Why is that the interval of convergence?
Aggro.
Well, okay, this makes sense. Why can't it be negative 1?
Because it's zero.
You can't take the
Because
natural
I
log
can't
of
take the
zero.
natural log of 0. So if I plug in negative 1, that's going to throw that off.
Jeez.
But why can't it be 1?
Why can it be greater than 0? I don't even get that.
Wait, say it again.
I feel like, I don't know, I feel like it'd be E rather than 1, just because, or no, E minus 1 rather than, because I feel like that at least makes sense, because then it's like,
Well, like this came from this one,
yeah,
and this interval of convergence was negative 1 to 1.
yeah.
Remember, the geometric ones only converge from negative 1 to 1. So if this is geometric and this came from it, this interval makes sense. I just don't know why it's equal to there, unless I'm wrong. Maybe I wrote it down wrong. Can I
Oh
check?
boy.
Yes. Let me just check.
Is every geometric
Nepal.
one
Every geometric one
relating to
Half
that
that dude.
1 over?
is
What time?
negative 1 to 1 unless that's
that like a
different. And then we have to
spin
put that in the
through or
interval. Like,
Yeah.
remember if this was like 3x? 3x then had to be between negative 1 and
But
1.
will everyone
Right.
like be
Bahama-
related to
Brahma-
1 over
Brahma
like 1
Putra River.
minus?
Not necessarily.
Brahma, but that's like
Just so
going
far.
through
So
China.
far, yes, but not
Yeah.
forever.
In Bangladesh. And then you got your Dhaka, which is in Bangladesh.
I can't even find it.
It's like
Dhaka.
Dhaka, it's like capital.
You got
Maybe it's not
Calcutta.
even in
Stop,
the
don't ruin the topic, don't ruin it.
I know, because
Don't ruin the topic.
there's someone that cuts.
South.
Calcutta's just on the right.
Oh, here
on
it
that
is.
side now.
And then Jaipur is on the left, and
Jaipur's on the
Madras is
right.
down here,
Jaipur is
Madras.
like Jasper,
Mumbai is
the black,
here.
really like-
Mumbai,
Hyderabad's
Agra,
smack down in the middle.
Delhi,
What did the
Tikapito, Hyderabad is
I
right there.
didn't really touch it. Well, now I'm touching it. Ha ha ha.
Oh. Maybe it's not equal to 1. I don't
No,
see
why
anything
check
The
them
really.
all?
Eastern Ghats, the Western Ghats, Hyderabad, Krishna.
It's pretty bad.
Alright, I'll take some
What's
I'll take some
Christian?
time when we're not together. I don't want to waste your time.
What's Christian?
Take this away.
Huh?
What's
I think I
Christian?
just messed up on my notes. It's not actually equal to. I don't see any reason why it
There we
should
go.
be equal to.
Goes through Hyderabad.
So, whatever.
I know
I'll try to
Hyderabad's
find
on
out if it is or if it's
Hyderabad, whatever.
Okay, there's another one.
Sri Lanka, Colombo, Jumbo Colombo actually.
Bakulma.
Bay of Bengal, Arabian Sea, Arabian Nights.
Oh, come on.
So put this down in a little list of ones that you know that the natural
Let me see
log
it.
of 1 plus x
What is that?
is the series that we just did. So it was x minus x squared over 2 plus x to the third over 3.
We know.
And it's, like, these are a lot to memorize, but it's really helpful if you get it and understand that this one came from the one before it. I just integrated it, and that helps me remember, oh yeah, this is to the n plus 1 over n plus 1. That makes sense because I just integrated it.
And the interval of convergence is the only time like that equals.
The only
Okay.
time this equals this is from -1 to 1, so we should write that down also. For all of these, the interval of convergence is -1 to 1.
So that one, we're not sure.
We're not sure, I have to double check it. For some reason my notes say it's equal, but I don't know if I just had a typo.
Oh boy.
Sorry.
Just can't believe
I don't see any reason why it should be equal, so. Okay, we're gonna get another one. Bring it on. Okay, this one comes from here.
So what are the four noble truths that lay us up? Desires that cause us up.
Yeah.
You have to detach yourself from the
Okay, do you
world,
remember
so
this
Ten equals that.
series from yesterday? I think we did this one, right?
What are the 5 precepts? It's just like don't rape, don't kill.
Yes,
Don't
you
do
did
drugs,
it.
We did it, right?
Don't kill.
It was
don't be a
like
sloth,
1
something like that.
minus x
That was a sloth
squared
one.
plus x to the
I
4th.
don't think that's it. I just lied.
Yeah.
Colin, did you just lie to me?
Pretty sure.
Colin's lying to me over here.
You got it.
Do you need another 4 noble truths?
And was it x to the
Or really?
2n?
What do you even need to know for this?
That's it?
Almost
Do we need to know,
Monsoons?
Yeah, it's
Sweet.
first monster.
We
Isn't it
need-
just like wind patterns?
Oh, we did X
Do we
over
need to know
that.
like Guadalupe or whatever?
Oh,
It's like
right, we did. Okay.
Chandragupta?
Yeah, do we know?
He's
So
his name.
this is a series that we know you could get it pretty easily. I maybe should have gone through it with you.
He was kind of cruel and then he gave up his power.
Okay. So if I were to get this series myself, I would have taken this one and replaced every x with x squared. So that's why x became x squared became x to the 4th, x to the 3rd became x to the 6th. Okay, every power got multiplied by 2, yeah.
Why isn't the first one just X then?
Because when I replaced, I only replaced the x's with what's there. So since it's a 1, I just keep it the 1. So here's a series that we know. What if I integrate this one? Major bonus points, not really, but for what's the integral of 1 over 1 plus x squared? Nope.
Oh, it's
Oh, isn't like this.
Partial fraction?
Not regular tans.
Is it arctan?
Arctan.
It's arctan.
Oh my god.
This is
This is dumb.
Always coming.
I don't even know what we're doing right now.
It's because you're showing Vulcan pictures or Falcons or.
Vulcan?
It's not me. I drew it. You keep on showing
Oh,
me.
look,
That's
we
what I'm
started
saying.
all again.
Look how good it is, though.
It's really amazing. But this is like the hardest stuff we've ever done.
I have no idea what this is.
So I'm going to integrate the other side as well and create a brand new series. So what's the integral of 1? X.
Yes, you got one right.
Yay! And the integral of x squared.
X cubed over 3.
Yep. Woo! And the integral of x to the 4.
X.
1 for 1.
That,
One, so like.
18.
Tell like he doesn't even.
So there's my series for arctan.
hamburger.
And the general term.
oh,
Oh, negative 1. Okay, we've got an alternator, so that's always good to put in.
X to the 2n plus 1 over 2n plus 1.
I think he might have this.
see, I don't know how to find that.
So how did what tipped him off to the 2n plus 1?
It has to be odd.
It was all odd numbers. All the powers are odd, all the bottoms are odd. Odd number means use 2n plus 1 to represent an odd number. An even number, which is how I got this one, is always represented by 2n. So since this one was always even, I put 2n. This is always odd, 2n plus 1.
So.
And now I just got to check out the n being from 0 to infinity and see if it works. If n is 0, so like, let me just say, if n equals 0, what term, like I'm going to have negative 1 to the 0 times x to the first over 1. Does that
First
equal what I have as the first term?
Yeah, you
Heck
just.
yeah.
Yeah. And if you want to just try it, if n equals 1, I'm going to have negative 1 to the first times x to the third over 3.
Oh my goodness.
So that over there is like back in 3rd grade when you're trying to find patterns with like.
Yeah, basically.
Alright.
So it does matter.
Yeah, right. This thing is like kind of finding your pattern, seeing that you're going it's switching signs,
So
using
will
all
it help
odds
us
and
find
all
the
odds.
triangle, square, pentagon pattern?
No.
What?
You guys don't remember doing those problems?
Is this the Da Vinci Code?
Where there were like
It's just the Da
squares,
Vinci Code.
triangles?
Actually.
Looks like
All right, so now we've got arc 10.
No.
Yo, I'll give him a blue hat.
Is that from -1?
Is this gonna be like a really
Yeah.
long list?
There's like 7.
D.
And we have to memorize
5.
them all?
You do need to know most all of them.
So all of them. That'll be fun. But I guess if you know like 2 of them, you
Yeah,
already know.
Yeah, you can get them all
Yeah.
from. You can get every one of these so far from the very first one.
Yeah.
This is a
You should be able to,
memorizing all of them.
in theory.
Yeah. If you don't know what you're doing, then it's really, really hard.
Yeah.
It's gonna be really, really hard.
Let's go with a blue hat.
It's a different kind of work.
I hate you.
Okay. That's the end of the list of series that come from other series in terms of like integrating them, differentiating them. You can still do it, but this is like most of what we do in terms of integrating a function that we already know or a series that we already know. So I even hesitate
Yeah, you should. We should celebrate Pi Day.
No, we're ready.
to
Let's
put it
go.
out there.
Let's go.
But we are also wanting to develop series for 3 things. We want one for e to the x.
Oh
We want
boy.
one for the sine of x.
I don't.
And we want one for the
you
cosine
do.
of x.
I don't need that.
I know.
No.
But what stinks is,
Wait, doesn't the sine of x and cosine of x, they come from each other? 'Cause
yeah, once you get one, you
integrate
can get the
sine.
other. Once you get one, you can get the other. But the problem is none of them come from these geometric things. These geometric things, it was easy to see how, not easy to see how, but you could see how you can get natural log and arctan from them. But e to the x and sine x and cosine x are like totally original. So, when you want to write a series, A, if it's geometric, it's kind of easy because you know what A and R are and you can write it.
Question.
Yeah.
Do you have like integral of convergence for arctan?
Oh yeah.
Oh, I think it's still -1 to 1. That's where it came from. I'll double check, but yeah.
That one has equal. So when in doubt, assume it's -1.
All of these, because they came from something geometric or -1 to 1,
Are those
now they're going to be infinity.
Oh snap! We're doing this.
Ooh,
amazing.
infinity.
Like negative infinity.
Okay, this is going to make your head
Oh my
hurt, but we'll
God.
just dip into it. There's something called a Taylor series. Taylor Swift?
Bryson?
And some crazy smart human being came up with a way to write a series for a function not based on Taylor series at all, totally from scratch. And it's pretty crazy.
It takes time to do that.
Now, I
Taylor?
went through the kind
Yep,
of
it was
the proof
Taylor.
of it a little
It was
bit,
Taylor Swift,
but
wasn't
it's so out there that I'm gonna just throw it down. And here's what it is.
Someone drop it.
There's an actual Taylor.
So,
I was gonna start throwing that.
Oh.
I would.
Oh man.
All right, so if we want to
Wait.
write a brand new series for a function like e to the x or the sine of x or the cosine of x, we don't have any place to start because I can't take an integral or derivative of an already known series. I have to use Taylor series. And Taylor series is just a name for a fancy way to come up with a series from scratch. So, how to write a series from scratch.
Kind of like Taylor making a game series.
For math.
Okay, because so far everything we've done has been based on something that was geometric that we could do. So if we want to write it from scratch, we got to use this thing. Taylor series looks like this. You're going to take the value of the original function at 0. Then you're going to add on the derivative of the function at 0 multiply it by x to the first, and put it over 1 factorial.
What's factorial?
No, obviously
It's
that's
like
just
1 times
I'm
1.
putting it there because there's going to be a pattern.
If there's
The next term is going to be the
No,
second
there's
derivative
more.
of the function. Well, it's a series, so I need to come up with a bunch of terms.
Times x,
Oh, wait, so
x squared
f
over
to the
Times
zero.
x squared over 2 factorial.
Okay.
Is that x first or x?
It's x to the to the first.
So
not,
f
not
of 0
derivative.
is the first term.
F of 0 is the first term.
God, this is weird.
And my next term is going to be the third derivative of f evaluated at 0
Who did
times x to
this?
the third over 3 factorial.
You know what I'm saying?
And
F to the
obviously I'll
fourth?
I'll
Is that
stop at this
possible?
one.
F to the IV.
Ha ha ha.
Roman numerals. Who
Not
gets them?
spam open.
Romans? Nope. Not even them.
We saw the numbers are the same in each one.
What's
Like,
that?
like it's like 3.
Yeah, it's pretty. It's not that. It's just like understanding where it comes from is a whole nother thing.
I feel like it'd be like insane to do that.
So it's not that hard to generate our own series now. I was gonna go through the process, like we could do this one, but it's just so annoying. Well, let's do it.
We're gonna do it.
Let's use Taylor series. To write a series for the natural log of 1 plus x. Because we already know what the series for natural log of 1 plus x is. So let's just use this new way and see if like it works. And if it doesn't, then I need to like go back to school. So the first thing I do when I use this is I go find all these derivatives kind of like to the side, so then I can just put them in the problem and do it. So like, if f is the natural log of 1 plus x, I guess do it like this. What's f of 0? If I plug 0 into this, natural log of 1, which is just
So
what?
just 0.
0. F prime. What's the derivative of ln of 1 plus x?
1 over 1 plus x.
Yay!
I think you need a piece of paper for this.
Maybe.
So the derivative evaluated now at 0,
1.
if I plug 0 in, is 1. Do you get what I'm doing, even if you're a little behind on just the derivatives? This is f, here's f of 0. Here's f prime, here's f prime at 0. Let's do the second derivative. The second derivative?
Oh man.
So now I would need like kosher rule, or I flip it up and make it to the negative first. So we're going to have
Cody,
1 over 1 plus x squared, quantity squared. And it should be negative, shouldn't it?
Yes, it should.
Yeah. Correct.
You don't know.
Of course I do.
Sure, make it negative. Do what you want.
So the second derivative at 0 then is
-1.
negative 1.
Since
Okay.
in the back.
Oh, so
So you're getting all these,
So alternate.
but what about the series?
We'll get to that in a
You plug it
second.
in.
So I haven't
Hold
plugged into
your
the series thing yet. I'm just going to go get all the derivatives,
Whoa,
or at least a few of them. The third derivative is then, if this is to the negative 2, this is going to be 2 over 1 plus x to the third. You can go do those derivatives out. If you have a question with it, let me know.
How do you get them? Just like.
I'm basically bringing this up and making it to the negative second. And then we're going negative 2 times negative 1 is 2, and then subtracting 1 from the power. So I'm just kind of doing it all at one step. So what is the derivative of this at 0?
Bet you the next one is negative 2.
I think it might be like negative 6.
Darn it. What even? I tried.
Because look, if I'm going to bring this up, and it's going to be like 1 plus x to the negative third.
Then you gotta drop it.
I got to drop it here, so we have a negative 6 over this to the negative 4.
Yeah, just the 4th.
Okay. Okay, so f to the fourth derivative of 0 is negative 6. That's probably good enough. So now I'm going to plug it into this formula and just go slowly at first, and then you'll be more comfortable with the formula. So the first term of this series should be f of 0. So it should be 0 plus. The second term of the series should be f prime of 0, which is 1, times x to the first over 1 factorial. I only put that in the formula so you saw the pattern. Obviously, don't need to write 1 factorial. Plus the second derivative at 0, which is negative 1, x squared over 2 factorial. Plus the third derivative at 0 times x to the third over 3 factorial. Everyone comfortable with how I'm plugging in?
Plugging what?
Are you comfortable with what I'm plugging in where and like what I'm doing?
Yes.
Imagine how
Fourth
excited this guy
derivative
must
at
have when he
0.
figured this out.
Negative 6.
He's
X
like,
to the
oh,
fourth over 4 factorial plus blah, 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 blah. Once you get like 4 or 5 terms, you can stop, because hopefully you'll be able to find the pattern that's happening. I then would reduce this. So my series, so natural log of 1 plus x, can be written as x minus x squared over 2 plus 3 factorial really equals what?
6.
6. Reduced with that
3.
is 3. Or minus. 6, 4 factorial is
6
4
over
times 3 times 2.
Yeah,
24.
6 times 4 is
24.
24. So it's x to the fourth over 4. Blah, 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 blah. Is that the series we already got?
Oh man.
Holy crico.
This guy must have been like psyched out of his mind. when he
Right?
found this out. Just died of a heart attack.
It works, and it works
He's
for
like, I
every
beat math.
series,
I
and
did
it's
it.
so cool.
I've bested the numbers.
Only that way is a lot faster.
So that
That way was a lot
you
faster.
have to get the series so you can get the general term.
Yes. Because, so in this case, let's say we had no prior knowledge of where it came from. Let's say we didn't know that we just integrated this to get to this, so we integrated this. If we had to come up with our own general term for this. This is the hard part, is my opinion, is how do you come up with a general term
Your
for it?
Ganges River.
So like, it's x to the power, and like once my powers are consecutive, I'm probably just x to the n.
Calcutta, Bhopal, Agni.
The numbers on the bottom match the power, so I can probably just put an n down there.
Alternator.
I need an alternator negative 1 to the n,
Then plug in stuff.
and plug in a couple numbers and make sure that works. If I plug in 0, oh that's sweet. If I plug in 0,
No, it works. Cause it's like 1 times.
Negative 1 whole plus 1. It needs to be n plus 1.
yeah, it does, doesn't it? Because look, 0. Okay, so
Oh, 'cause it's over.
either
Yeah.
0 won't work. Will this work if I started at 1?
I hope so. Next.
Yeah, if you started at 1.
It'd be negative 1.
because it'd be negative.
Yeah.
Okay, so I'm going to have to go n plus 1, n plus 1.
Yeah.
And that's why a lot of times you have some of these memorized, because that was easy to see before when we integrated, now not as easy. That's what you really have to check, at least the first term, to make sure you're right, or else you'll like miss something little.
Caper.
Alright, I'm so curious. Try it tonight.
No.
Try to write a Taylor series for this one.
We're gonna do
I
it.
don't even know what
Alright, we got it. We're gonna do it.
You can so do
We're not gonna
it.
give up
E
after
to the
what?
x.
12 seconds like last.
Wait, is it just you got e to the x?
I couldn't figure
Yeah.
out that
It's
problem.
gonna be
If it says X,
But it's x to the
you
e.
were like,
Which switches it up on?
So it'd be e to the n.
you did not
Derivative
it
is
was
always going to be e to the x.
21
So
plus
it'd just be e to the
21
x.
plus I was 0. sitting there, but you
So
were
an open-ended problem is most likely going to be used with this, and then it's going to make you make one up, and we'll have like a
Alright,
graph or
Falcon
something
out.
probably too.
No, you probably want to graph it.